Hello everyone. In this presentation, I am going to cover design of longitudinal drawing of highway drainage system. Okay, which will included in the subject highway engineering under the module number 5. Okay, this highway drainage is an important component in highway construction. The objective of providing highway drainage is in order to drain off rainwater as early as possible from the road surface. We are constructing this structure. Okay. Now we will see how to design this longitudinal drawing. But before going to this longitudinal drawing design, let us give a brief introduction about this longitudinal drawing. This longitudinal drawing here we are designing, which is having a shape of trapezoidal section. Okay, and the main objective of this longitudinal drain is, as soon as rainwater falls on the road surface, it has to flow to the side drains that is provided at the edge of the road, or you may call it as longitudinal drain. This drain will show a path for this flow of water to the water streams. Okay, with this small introduction about longitudinal drain, let us start how to design this longitudinal drain. Okay, now, so in this presentation, I am going to cover how to design longitudinal drain for highways. Okay, whenever you start any design in civil engineering, the first thing what required for you guys is you required certain data. For that data, you have to design the given structure. Correct? No? As you know, for different loads on the building, we have to give different dimensions of columns and beams in the building. Correct? No? Similarly, if you know the capacity, then only for that capacity you can design any civil engineering structure. Therefore, you need data for any design in civil engineering structure. Here comes one problem with respect to design of longitudinal drawing. In this problem, they had given the data. For that data, you have to design the drawing. Okay, what is the data they had given? They had given that the maximum quantity of water expected in one of the open longitudinal drain on clayey soil is zero point 0.9 meter cube per second. That means there is a longitudinal drain. That longitudinal drain should have a discharge capacity of how much? 0.9 meter cube per second. That means per second 0.9 meter cube of volume should flow off in that channel. That is designated as alphabet Q. Okay, discharge value that is. Next, design the cross section and longitudinal slope of trapezoidal drain, assuming bottom width of the trapezoidal drain is how much? 1 meter. He is saying that discharge in the channel we are expecting is 0.9 meter cube per second, and also he is saying that assume bottom width of the trapezoidal section as 1 meter. Okay, and also he is saying that assume cross slope being 1 vertical is to 1.5 horizontal. Okay, also he is saying that the allowable velocity of flow in the drain is 1.2 meter per second. That means he is saying that in that channel water will flow with a speed of 1.2 meter per second. Here I am going to indicate speed in terms of v. Okay, and also he is saying that Manning's roughness coefficient is given by the value 0.02. This is n. So in this problem, what is the data they had given? He is saying that discharge in the channel is expected to be 0.9 meter cube per second, 0.9 meter cube per second, and speed of the water in the channel we have to maintain for about 1.2 meter per second. That is the expected speed in that channel. Now also he is saying that Manning's coefficient is given by the value 0.02. Now we have to design a trapezoidal section which will have a discharge of 0.9 meter cube per second and which will have a speed of flow of water in that channel will be 1.2 meters per second, and also he is saying that Manning's coefficient is 0.02, and also he is saying that bottom width of the trapezoidal section you can assume it as 1 meter. Now what is my suggestion is, before going to the solution part, let us indicate all these in a diagram. Okay, we are going to indicate all these things in a diagram. Now what is the diagram? Diagram is saying it is a trapezoidal section. Trapezoidal means all of you know that this is the section, correct? No, this is how trapezoidal section will come. Okay, now as per the data, what he is saying, bottom width, okay, drain assuming a bottom width of trapezoidal section to be 1 meter. He is saying that this is equal to how much? 1 meter. And he is saying that slope, how much we have to provide is 1 vertical is to 1.5 horizontal. That means for every horizontal width of 1.5, you have to increase the vertical width of how much? 1. Okay, he is saying like this, 1.5 horizontal is to 1 vertical. For every width of 1.5 or every length of 1.5, we have to give an vertical height of 1. That means if you join this, you are going to get this. So that is 1.5 horizontal is to 1 vertical, or 1 vertical is to 1.5 horizontal. Here he is saying that it is a cross slope or side slope. That means what he is saying that if I just put a dotted line here like this, you can see the diagram what I am writing. Okay, suppose horizontal will be 1.5. Here also you can take horizontal is 1.5. This vertical is how much now? We have to give slope 1. So this depth I am going to indicate it as D. I'm going to indicate the depth of trapezoidal section will be D. Obviously this distance is how much as per the slope given. This will be equal to 1.5 into D, 1.5 into D. Okay, I hope all of you are following what I am saying. Therefore, slope here, if I am indicating the depth in terms of D, means as per the slope they had given, this horizontal distance will be 1.5 into D, and this horizontal distance will be 1.5 into D, and this is equal to the bottom width. That means bottom width they already given in the problem, it is equal to 1 meter. Obviously, this distance is also equal to 1 meter. Now, my question is, what is total top width and what is total bottom width? So top width will be 1.5D plus 1.5D plus 1. Therefore, that will be equal to how much? 3D plus 1, or 1 plus 3D. And bottom width is equal to how much? 1 meter. You required this expression to solve the problem or to do the design of this longitudinal drain. Okay, I hope all of you understood how you had just written the data in the diagram, converting that problem data into the diagram data. Okay, now the thing is, we'll move on to the next step. Step number 1 is design of cross section. I hope all of you know design of cross section means you have to calculate what is the depth requirement for the given data. D you need to calculate. You can see in this diagram. D you need to calculate this D value. After getting the D value, you have to calculate bed slope value, and that ends your design of longitudinal drain. Okay. You may ask, sir, what is this bed slopes, sir? Bed slope means, see, if you want to provide any bed slope to the longitudinal drain means water will retain in its stagnant state. Correct? It won't flow off. To give a gravity flow, you have to give slope to your longitudinal drain such that water will take its path through gravity only. There is no requirement of any extra force for the flow of water in the drain. Okay, if you provide bed slope, that's why we have to calculate how much bed slope we have to give and what is the depth of the trapezoidal section we have to provide in order to get 0.9 meter cube per second discharge, and in order to maintain speed of water in the channel 1.2 meter per second. Okay.